So this is the first video of Chapter 7, where we're going to be talking about alkenes. And so similar to Chapter 6, we're going to first talk about the nomenclature, right? So we're going to add more IUPAC naming tools to our skill set. And then we're going to be talking about a new kind of reaction set called eliminations, which will look pretty similar to the substitution reactions we learned in Chapter 6. So firstly, right, alkenes are different from alkanes because alkenes are carbon-carbon double bonds, while alkanes are carbon-carbon single bonds. In general, and we'll see this a bit later, but alkenes are more reactive than alkanes due to those unhybridized p orbitals that they have. So for rules for naming alkenes, it's going to be pretty simple for the most part, but essentially, and we'll go over some examples here to make sure we don't fall into any issues here, but in general, the longest continuous chain containing both carbons of the double bond is the root, and the suffix is -ene, right? So not like alkanes where ane, right, A and E is the root. Now we have ene as the root. And we'll see this in a little bit, but if we have more than one alkene in our molecule, we'll have to denote it as such, right? So if we have two alkenes in a molecule, the suffix will be diene. If we have, for example, 4 alkenes in a molecule, we'll have tetraene as our suffix. And finally, the root is numbered from the end that gives the lowest number, right? So we always want to have our molecule with the lowest numbers possible to the first carbon of the double bond. And so the number of the first carbon in a double bond is indicated in the name. So for example, with number 1 here, right, if we go ahead and count this molecule, right, we know we have 4 carbons, right? So we know this is butane, but we have a double bond here. So it's not butane, right? It's not A and E for an alkane, but it is ene for an alkene. So we would have to denote it as 1-butene. Right, and here the 1 designates where the ene is in the molecule. Okay, so 1-butene means that the 1 position is where the double bond starts. Another way you could do this, and I'm not going to do this because I think it looks kind of weird, but another way that sometimes you'll see things denoted like this is as such, where it'll be but-1-ene. But I will be naming the molecules like this, but you might see structures like this in your book, or if you ever search up molecules, or in future chemistry classes. So for the second example here, right, we're making things a little bit more complicated by adding a substituent, and we will want to name it this way, right, because the alkene starts at number 1, right, and we want to have the lowest numbers possible. Okay, so even though the methyl is on this carbon here, if we started from the methyl, we'd have 2-methyl, and then we would have 4-ene at the end here. So when we name this, it would be 4-methyl 1-pentene, right, with that E there instead of the A. And the 4-methyl comes first because the 1, right, kind of standing on its own here without any substituent, again, is indicative of the alkene feature. So looking at our final example here, right, so we have 2 double bonds. And so what this is indicative of is the diene suffix, right? And so when we're naming this, we would want to go this way, again, to make sure we have the lowest numbers possible. So we start from the alkene. And so when we try to name this, similarly, we get 4-methyl, but now we have 1,3-pentadiene. Move this over here to give us some more room. Pentadiene. You notice a couple things, right? That we have not only, right, 1,3, and that's indicative of the 1 is where the double bond starts, and the 3 is where the double bond starts, okay? You also notice that we have, right, diene. Again, meaning to note that, right, so we can tell whoever's reading the name that, okay, yeah, there are 2 alkenes here. You also might notice there's a little a here, and that's kind of just a grammatical thing, right? Because pentdiene sounds kind of weird, so the a is there to make the name sound a little better, right? So if you ever have to name something like this, right, if it was hexdiene, we'd want hexadiene. So the a is just sort of to bridge the 2 consonants here. So changing gears a little bit here, let's go ahead and talk about the stereochemistry of alkenes. Okay, so just some minor terminologies up here in case you're a little rusty on stereochemistry. But right when we're looking at an alkene, there's a few different ways that we can view it. So right here we just have general labels here, A, B, C, D, right? These are not chemical or atoms, they are just designations. And for a alkene to be a stereoisomer, each carbon here has to have 2 different groups, right? So this carbon has to have 2 different groups on it, and this carbon also has to have 2 different groups on it, okay? And so when we're looking at these 2 examples here, we have to consider, are these stereoisomers? Okay, and so they are right off the bat different molecules. This one alkene has 2 methyl groups on it, and this alkene has 3 methyl groups on it. So when we're looking at this molecule, we have to say, okay, this side of the molecule has 2 different groups, right? It has a methyl and a hydrogen, and this side of the molecule has 2 different groups. So we know that this is a stereoisomer, right? And if we were to draw the other stereoisomer of this, and we've kind of seen this already, right? If we switch the position of 2 of these groups, we get the resulting stereoisomer, right? This is the cis-trans stereoisomer, right? Where this one on the top is the cis isomer because the groups are on the same side, and this is the trans isomer. And over here, right, we can't do that anymore, right? Because if we end up switching, right, these 2 groups, we just end up with the same molecule. Right, nothing has changed here. Because we can just rotate this molecule around in order to make it superimpose on top of itself, right? So this is not a stereoisomer, and this is a stereoisomer, right? So to go into a little bit more detail with cis and trans, right, because what we've learned previously is cis is when the same groups are on the same side, and trans is when the same groups are on the opposite side. So what if we have 4 different groups here? Then what? Right, we can't really use cis or trans designations anymore, so we'll have to switch up our terminology a little bit here. So in general, and this is going to be kind of similar to R and S naming, is when we have a molecule with different groups attached to the carbon, what we have to do is look at the priority. And what I mean by that is just like R and S naming, where on one atom, we want to look at the highest priority on the bond and the lowest priority. And when the high priority groups are on the same side, like here, that is the Z isomer. Right, the high priority groups are on the same side of the double bond. And when the high priority groups on the opposite side, like here, right, we see the high priority on opposite sides, right, compared to the double bond, we have the E isomer, right? And you might be tempted to call it cis or trans, but there's nothing inherently wrong with that, right? We could say the Z isomer is also the cis isomer. You'll see here in a second, it gets kind of weird with naming when you try to do that. So let's go through this example here really quick. So the general rules for assigning priority, right, is very similar to R and S, where looking at this side of the carbon first, we want to assign the priority based on the atomic number, right? So we know that chlorine, right, is bigger than fluorine. So we'd say that chlorine has the higher priority, right, it's 1, and fluorine is 2. And looking at this side of the molecule now, we know that carbon has a higher priority than hydrogen, right? So we know that these the high priority groups are on the same side, So we know we have the Z isomer. So how do we name this now? So if we're going to use our IUPAC naming, we have to now consider putting in the Z here. And so I'm going to erase some of this clutter here. So now we have to look at the carbon chain. So we know we have a carbon here, and a carbon here. So we know that this is propene, or one propene rather. And we have two groups coming off of that carbon there. So we would say that we know we have one chloro and one fluoro. And so we have to put all the pieces together here. And alphabetically name this one chloro, one fluoro, one propene. And so now, we have to say whether this is Z or E, because if we weren't given that, we'd be trying to draw this molecule, and we wouldn't know where to put this methyl group, We wouldn't know whether to put it down here or up here where it is. So we would have to say that this is 1Z, one chloro, one fluoro, one propene, Kind of just like RNS naming, Where you would put the number of where the stereochemical designation is. So we'll get some practice with naming some of these, and they won't be anything super complicated, Because we could definitely go through examples and have tons and tons of different stereochemical features. But we won't do that, so we'll just go through some simple examples in class. So we'll go ahead and look at these, where we're just going to assign the E or Z designation to these molecules, and we'll go ahead and go through some more naming examples as well.